Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Anomers, stereoisomers that differ only at the anomeric carbon, C1, of a cyclic sugar, all other stereocenters are identical. Epimers, stereoisomers that differ at exactly one non-anomeric stereocenter, all other stereocenters including C1 configuration are the same. Moving on to the next step. Looking at the ring substituents, structure I has OMe at C1 in one orientation, alpha, axial, and structure 2 has OMe at C1 in the opposite orientation, beta, equatorial. However, examining the substituents at C to C3 and C4, they are also different between I and II. The off patterns differ at multiple centers beyond just C1. Specifically, I appears to be alpha-glucose derivative while II appears to be a different sugar. The off pattern at C to C3, C4 is inverted compared to I. Therefore, I and II differ at C2 or another non-anomeric center, making them epimers, differing at one non-anomeric stereocenter. Moving on to the next step. Structure I has OMe at C1 in alpha configuration. Structure 3 also has OMe at C1 in alpha configuration. The ring substituents at C to C3, C4 appear to be identical between I and III, both show the same OH arrangement on the ring. The only difference is at C1, I is alpha and III could be. Wait, re-examining, I has OMe alpha and III also has OMe alpha. Actually, comparing I and III more carefully, they have the same configuration at C1, both alpha OMe, but the same non-anomeric stereocenters as well. Re-examining the structures, I and III have the same base sugar skeleton but differ only at C1, the anomeric carbon, making them anomers. And for the final step, 3 has alpha OMe, axial, and 4 has beta OMe, equatorial, at C1. The non-anomeric substituents, C to C3, C4 of pattern, appear identical between 3 and 4. This means 3 and 4 differ only at C1, they are anomers of each other. I and II share the same anomeric configuration pattern, but differ at one non-anomeric center, example, C2, confirming they are epimers. Option D states I and III are anomers, I and II are epimers. This matches our analysis. I and III are anomers, same sugar, differ only at C1, and I and II are epimers, differ at one non-anomeric stereocenter. Why other options fail? A says I and II are anomers, incorrect, they differ at non-anomeric centers too, epimers. B says I and III are epimers, incorrect, they are anomers. C says I and II are epimers and 3 and 4 are anomers, partially correct for 3-4 but misidentifies I-II relationship, and option D better captures both relationships involving I. Therefore, the correct answer is D. Therefore, the correct answer is option D.